Okay, that was fun. Go away. Okay, perfect. So we need to fill this in. Adding and subtracting is the least easy one to figure out. Is that true? Mm-hmm. Okay, so let's skip it. Let's go on. Let's do multiplying and dividing. Right? Like, let's do the easy stuff first. So multiplying and dividing. Who came up with an answer for that? What do you do? Go.
We added all the uncertainties.
Add the
percentages.
Oh, perfect. Okay, so when you multiply and divide, you're going to add the percent uncertainty.
Yeah.
Do we agree with that?
Yeah.
Does that make sense?
Yeah.
Can somebody give me an example of one of the questions from the pink sheet that helped you to make that conclusion? Or it just was like, it just came to you? Poof!
3.
Number 3. Can you tell me a little more, Brittany? Like, why on number 3 did that help you?
Because density is mass divided by volume.
Okay.
So when we knew it was 12 and 2 plus 10.
12. Yay, we can add. Awesome. I love it. Okay, perfect. Okay, so we're happy with multiplying and dividing. We add the percent uncertainty. How about exponents? What do you do with an exponent? Go.
Do you, okay, I'm just going to guess here, do you like multiply by the value of the exponent?
What do you guys think?
Yeah.
Yes.
Yeah, you multiply what by the value of the exponent?
The percent uncertainty.
Boom, yeah. You're going to multiply the percent uncertainty by the exponent. And really, if you think about it, and I'm not saying like, duh, you should have known this, but just to kind of point out that it is pretty obvious that it works. If you have x times x, so that's multiplication, then you would add the uncertainties, right? Or if you write that as x squared, then you're going to take that uncertainty and multiply it by 2. Like it does logically make sense. Yeah, so that's kind of nice, right? Yay! Logic. Okay, and so which questions may have helped you to come to that conclusion?
1 and 4. 1 and 4.
1 and 4, right? And in order to do 1 and 4, you kind of needed to know the multiplying dividing stuff too, right?
Yeah.
So we're kind of putting those two together. Everybody's happy with these guys? All right, so then we have to go to this addition and subtraction business. Yes? And there's only one, because you already said 1, 2, 3, and 4. There's only one left that might help you with this one, number 5. Does anybody have an idea? An inkling of something we could do to figure out what the rule is here?
We know that like the product of subtracting is bigger than that of adding.
Okay.
That's a fact.
We know that because we know the answer is C. Yes. Okay. So that's going to help us get there, right?
I don't know if this quite makes sense, but could it be that because the number, like, for, like, when you said plug them in, the range for C was like negative 9.9 to negative 10.1.
Okay.
And the range for D, it would be with a larger number, so the percent uncertainty of the large number of like the variables that it could be would be smaller than the smaller number, the smaller negative number.
Okay.
Is that everything to do?
You're on the right track. It's kind of like a different route. Like I feel like the route that I'm thinking, and I'm going to walk you through in a second, goes like this, and yours goes kind of like that.
Okay.
Does that make sense? But you're going to get to the same spot. Now, I do realize that the wording was a little funny. This is also called fractional uncertainty. I hope that kind of makes sense, right? Because it's like written as a fraction. So okay, I apologize for that little bit of I don't want to say misleading, but lack of putting that in there. So let me say that this is fractional uncertainty as well. Okay, so let's play with those addition subtraction ones. So if we were going to find ft, the fractional uncertainty in t, that's just going to be delta t divided by t. So let's go ahead and figure out what that value is. If you don't have a calculator out yet, go ahead and pull one out because we'll need it a couple times today. So let's just get it out now. And once you have it out, go ahead and figure out what delta t divided by t is. So that's just going to be 10 divided by 0.1, right? You might even be able to do that one in your head. What do you get? 100?
Yeah.
Do we multiply it? Yeah? Okay. How about, delta S divided by S? We could probably figure that out logically as well, right? You don't actually have to like plug that one into your calculator. Plug it into your brain and figure it out. Okay, so then we are left with delta t minus s over t minus s and delta t plus s over t plus s. We have to figure out what in the world that is. Well, we can figure out these values pretty easily, right? Okay. So the t minus s is going to be 10. And the reason that I'm going to say it's not negative 10 is what? Anybody catch this?
Because then you can't change negative, like you can't have negative delta.
Well, you could, kind of. There's a word in the question that will tell me that I really don't want it there.
I love the delta meant answer. So why shouldn't it be like 0.1? Yeah.
What did I do? Oh, did I flip it over?
Yeah.
Oh my gosh, that's totally embarrassing. I'm sorry.
Thank you.
No. Gotta call me on stuff like that, right? I'm just going fast. I'm watching the clock going, oh my gosh. So yes, it is. Let me flip it over. Sorry about that. So 0.1 over 10, thank you, and 0.1 over 20. And so this should really, which makes a little more sense, right?
Yeah, 1/100 and 5%.
What's that? Whoops. Whoa, come back. Here we go. And what?
1/200. Yeah.
Thanks for calling me on that, Michael. Appreciate it. All right. Thank you for that. What's t minus s? What do we say?
1 divided by 20 is 0.10.
Could be 0.
Yeah, 0.1 divided. Yeah, 0.1 divided by 20 is 0.005.
0.0.
0.05.
Thank you. Now we happy?
Yeah.
Okay, so we can divide. Carpelin can write things down correctly. Let's get to the ones that we care about. These are the ones we really care about. What's t minus s, friends?
10.
10. Why is it positive, not negative?
Negative 7.
There's a word in the question. Read it carefully. What's the word? I suppose that wasn't the word I was looking for. I was looking for the word magnitude. Yeah, that's what I was really looking for. But yes, length, I suppose you could kind of argue. This one's going to have
30.
30, thank you, because it's 20 plus 10. And the t minus s and t plus s, what is that going to be? Any ideas? Brainstorm. You don't have to be right, friends. It's the beauty of being in a class, right?
The percentage. You get to subtract the percentage uncertainties, right?
I don't know. That's what I'm asking. Is that what you want to do?
I think.
So what are you suggesting? Can you tell me what number you're suggesting I write down?
Yeah, I'm suggesting that we take the change in t minus s, which is the uncertainty, so the uncertainty of t, which is 0.01, but you're going to make that a percentage. So 1% minus 0.5%, really.
So you want to put these two numbers in here, is what you're saying?
Yeah.
Okay, so we could accept that this is really just an error as well, right? Does that make sense? So it's not... Okay, so am I understanding, can I ask this question correct? I want to ask a question. Does that mean you're kind of like splitting these apart and saying that this would be like delta t over t minus delta s over s? Yeah? And then maybe we could try delta t plus t over delta s plus s? Does that sound like something that, does that sound like what he's saying? I'm just asking because I want to know.
Yeah,
Okay, so if we try that, let's try it. So that's going to be, this one would be 0.01 minus 0.005, which is going to give us how much?
0.005.
I hope so. Go away, thing. X, how do I undo you? Why won't you go away? There, whatever, okay. 0.005, And then according to that theory, then this is going to be 0.01 plus 0.005,
Yeah.
which would be,
0.015.
and does that lead us to the conclusion that we want?
Yeah,
Yeah?
because
Which one do we want to be biggest?
T minus S, and because 10 is smaller than 30.
Yeah.
No, but that's not what Will was saying.
No.
He's saying we're just going to take, I think, I'm not trying to put words in your mouth, so tell me if I'm not saying this accurately. It sounded like you were just trying to split that apart, right?
Yeah, changing T over T minus changing S over S.
So that's this guy.
Yeah.
So this would be your answer.
Yeah.
Okay. And then this would be your answer.
That doesn't make us.
That doesn't give.
And that's not the right answer. It was a good choice, a good guess though. So good work. Thanks for putting it out there. I appreciate it. But do you see what I'm saying? Like, I'm not like just like wrong, but like it doesn't lead us to the right solution.
So wrong.
So wrong. But it's a good start.
Where do you put 0.27?
Where do you want to put it? Here
Yeah, and on the bottom.
and here. Where did you come up with that? Just like a good.
You take they're both plus or minus 0.1, so the greatest difference is 0.2.
Does that make sense to you guys? Do you see what she's saying? Okay, so you're saying, so 0.1 plus 0.1 there and here? Okay, so let's try that. So maybe let's split the room in half so we can do this fast. So like if you 3 tables do the minus one and you 2 tables do the, or 3 tables do the plus version, let's see which one, and we can actually figure that out pretty well, which one's going to be bigger, right? Which one has the smaller denominator? But let's figure it out just to make sure and make sure it's not somewhere else that we don't want. So if we use Ann's theory, what's this value here? You guys understand what we're asking? So what did you get? 0.02?
And then 0.006.
0.006. And now if we look at all 4 of them, 1, 2, 3, 4, which one's the biggest?
T minus S.
There you go. That is the correct answer. Yes. That is how you do it. So we're going to write this down in our list. So let's look at that list again. Woo! Adding and subtracting. What is it that you were adding? What is it that Anne suggested that we add?
Add the actual uncertainty. That's what she did.
What did she add?
Yeah, the uncertainties.
The errors. Yeah, these are the, so uncertainties when you're actually dividing by something. The errors, yeah. Does that make sense?
Okay.
Yeah, and it kind of seems like in real life words, like it shouldn't matter, right? Error, uncertainty, whatever. But they actually have technical terms, and that's why I want to keep that straight. Okay, so we're going to add, I'm going to call it the raw error, just so we don't forget that that's what it is. So it's actually the plus or minus values. Okay, are we good?
Yeah.
Yeah? Awesome. Now I want you to pull that blue sheet out. I'm going to give you 5 minutes with your table mates to talk through it. If you didn't have this stuff figured out before, then you may want to take a look at numbers 10, 11, and 12 now, okay, because I think that they may be a little more clear. But also take a look at the front. One question that came up before all of you got here was the word gradient. What does gradient mean?
It's a fancy word for slope.
Fancy word. It's an IB word for slope. Yes. Okay, that's all it is. So 5 minutes. Discuss. If you don't need quite all 5, then we'll move on faster.
Let's just go.
Go through it. Go, go, go.
Oh, right.